Okay guys, today we're going to dive more into the different types of graphs. We're going to start with histograms. Now we kind of talked about histograms last class. A histogram is just a graphical representation of a frequency distribution. Now, when you graph a histogram, just a reminder that it has a numerical x-axis and the bars will be touching. And when you graph it, you can get a couple of different results back. The first one that you can get back is symmetric. And a good description of symmetric is if you split the histogram down the center and the left and the right sides are approximately mirror images of one another, it would be symmetric. So a good example is if your histogram kind of has this shape, it's the same on the left as it is on the right. It can also look like the opposite, which is going to look weird. It can look a little bit like a bowl, like over here. That would still be symmetrical, same on the left as it is on the right. The other way that it could look is skewed. Skewed is non-symmetric distributions that extend more to one side than the other. Now there's two different types of skewed. We have skewed left and skewed right. Skewed left and skewed right is based on where the tail is. So if you have a histogram that is skewed left, the tail is going to be to the left of the peak. So it's going to look something like this, where like a lot of the data, the tail, it looks like it's trailing to the left, whereas skewed right is going to be the opposite. It's going to have the peak over here and the tail is going to be over here to the right. Skewed right, the tail is to the right of the peak. So down here we have three different options and it says from the graphs, please choose all applicable answers. So they want to know if it's symmetric, skewed left, or skewed right. So if it's symmetric, I would be able to draw a line right down the middle. It would be the same on the left as it is on the right, and that's not what's going on here. So that means it either has to be skewed left or skewed right, and it all depends on where the tail is. Here the tail is to the right of the peak, so that means it's going to be C, which is skewed right. On my middle guy, everything looks kind of the same. Some people get a little worried because they're like, well, this is taller than this. It's pretty close to the same, so that's going to be symmetric, which is A. And over here, clearly we have most of the data over here on the right, so the tail is to the left, so this would be skewed left, which is B. Next, it says make a histogram for the birth weight of newborn babies. We're just going to briefly and quickly go through how to make a histogram by hand because I've done this a million times. It's just going to be a nice little refresher. First thing we need to talk about is a title. Title tells me exactly what's going on in the graph, and here we're talking about the birth weight of newborn babies. Make sure that it is accurately capitalized. Birth weight of newborn babies. Now we have two categories here. One needs to be the x-axis, one needs to be the y-axis. The weight in pounds is going to be my x-axis, so weight, and I always label it in pounds. And then the number of babies is going to be over here, but we need a better way to say that. Number of babies doesn't really sound right, so we call it frequency. That would be like frequency. Notice how I turn my pen and I write left to right. We're not going to write on top of each other like that. That's not a nice way to read things. That's not how we're going to write things. Now we need to take our categories and we need to come up with a good scale. So here it's been broken up into our categories 5 to 5.9 all the way to 10.10.9. Now since this is a histogram, we are labeling the bars, not the lines. So I'm going to turn my page again and I'm going to write accurately. So I'm going to say 5 to 5.9 goes there, 6 to 6.9, 7 to 7.9, 8 to 8.9, 9 to 9.9, and 10 to 10.9. Now for my frequency, we have to come up with a scale on our own, so we need to find the maximum value, which is 14, and we need to find a scale that's going to fit. So I'm going to label the lines here. I'm going to have 1, 2, 3, 4, 5, 6, 7. If I need to get to 14 and 7 lines, I can count by 2. So I'm going to start down here at 0 and count by 2. Now once you have your scale, you're going to come in and make the bars for each of your categories. So my first category here is 5 to 5.9. And we had 4 babies born at that, so I have a frequency of 4. So I like to keep things nice and neat and straight. So I'm going to use a straight edge, and I'm going to come in here at 4, make a straight line across and down. And then before I move on, I label that so I know exactly where I'm at. I say that is at 4, and then I do some kind of shading inside of it so I can clearly see what's going on, because if you're using pencil, it's hard to see. So some people like to use a highlighter and color it in. You can use your pencil, it doesn't matter, just so that if I look in there, I can see. Then we're going to do the next category, which is 6 to 6.9. There were 12. That was a frequency of 12, so that's all the way up here. Connect it down, and again you're going to come up here and you're going to put 12 and you're going to shade so I can see. So next what I want you to do is I want you to pause the video and finish this histogram. Okay, once you finish it, it's going to look something like this. This is nice and neat and easy to see. You can see that the highest frequency category was 7 to 7.9 pounds. Next, what we're going to talk about is we're going to talk about how to do this on Excel. Now, we did something similar to this last class, but this is a little bit different. Last class, what had happened is we had just the raw data. We didn't have categories. We needed to create our own categories, whereas here, it's already been broken into categories for us. So I'm going to teach you how to put that onto Excel and create a nice histogram. So the first thing I want you to do is open an Excel document, and you are going to copy this table into Excel. I don't have it for you on Canvas. You're going to need to get some practice into copying data over accurately. So when you copy it over, it needs to look something like this. So go ahead and pause the video and copy the data over. Once you have that data copied, I'm going to show you how to accurately make the graph. Now, some people like to put it in columns instead of rows, and that's okay. It shouldn't make a difference. So what you're going to do here, and again, these instructions are in your practice, is you're going to select the entire data set. So I'm going to highlight the whole thing to make sure the entire data is what we're looking at. And then you're going to go to the Insert tab. Now on the Insert tab, you're going to see all of these popular choices for charts. But we want to make sure we click the right one. You're going to click on Insert Statistics Chart, which is not this one. That is a column or a bar chart. That's not what we're looking for. You're going to come right here, Insert Statistics Chart, and you're going to drop it down, and you want a histogram, so you're going to click the first one. Now when it first pops up, you're going to be really freaked out because this is not at all what we're talking about. But the thing is, your Excel document doesn't know that you already have data or categories for them. So we just have to tell them to use the categories that are already there. So to do that, you're going to come down here on the axis that you want to fix, and you're going to right click. And once you right click, you're going to click on Format Axis. Now all of these options are let me get rid of this here. All of these options, get out of here, are going to pop up, and you just have to choose the right one. Now right now they have automatic, but we want it by category. So if I click on by category, what it's going to do is it's going to change your histogram to use the categories that you have already made, and that's exactly what we want. Now, all of these options are things that you can figure out if you would like to in the future. On your practice, I have kind of a breakdown for each one of them. By category is what you do when you have the text categories entered. Automatic is what you do if you want them to choose it for you. Bin width is kind of nice if you have a big data set like we did last class. So if it looks something like this, you can come over here and you can insert, you can do histograms, and you can play around a little bit and you can say, all right, so I want bin widths of 33. You could type that in and click enter, and it's going to automatically create bin widths that are $33 wide. You could also go by number of bins. So if you say I want 7 bins in this histogram, it'll create the exact ones for you, which is really nice. Now the overflow and underflow bin are for if you want to look at specific data. So like here, if you say I want to know exactly how many companies had average closing prices over, let's go $150, and you put that in there, and it'll adjust so that if it's greater than $150. And then the underflow is the same thing. So if I want to know if it was less than $50, so that it would group it accordingly. Now back to the one that we're currently working on. This is where we're at. We want it by category because we already have that. Then you can close out of this. Now, you'll notice our histogram is missing a lot of information that it should have. For example, it's missing my axis titles. Easiest way to get those on is you're going to click this little plus sign. This little plus sign, you're just going to click on axis titles, and they pop up. Now, you are going to have to double click, and you're going to have to name them accordingly. So this would be weight in pounds. And this, you could go number of babies, or you could do frequency. I'm not picky. Either is okay. And then you need to change the chart title. Now if you're like, I don't know what to name this chart, you can look back at your practice, and we found a pretty good title of birth weight of newborn babies. Then another thing that I like to do, again, I just like data labels because I don't know what's going on here, so I'm just going to come in here and put data labels so I can see exactly what each one measures. And if you want to change the color or how it looks, you can come up here, no big deal. And finally, I like the borders. Let's get rid of this. I like the borders to be black so I can see, but you do not have to do this. I just like a solid line of black just so it's easy to see. And that's how you do it on Excel. Now, the difference between using this function that we just used and the one last class with the data analysis pack is really all dependent on that frequency chart. If you want the frequency chart with it, like we did in the class last time, then you need to use the data analysis pack. But if it's already given you a frequency chart, you don't need to. You can use the insert function. Now the next thing we're going to talk about is a stem and leaf plot. A stem and leaf plot is just a nice way to organize data values from smallest to largest, and it also kind of gives you a visual representation of the data. So here it says construct a stem and leaf plot of 20 of the fastest land animals that are listed in the table below. We're just going to take these values and put them in our plot over here. Stems are the tens places, leaves are the ones places. We want to put it in numerical order. So I want to find my smallest value here, which is 32. So the 3 is going to go in the stem, and the 2 is going to go in the leaf, and then I'm going to cross it off so I don't use it again. Then I'm going to find the next smallest number, which if we look here is another 32. And you want to leave the 3 from the stem there, and you're going to add another 2 for a leaf, and then you're going to cross it off. So this right here is actually two numbers, 32 and 32. And then you're just going to keep going in order. So the next smallest number that I see is 35. Then I have another 35. And then we're going to have a 36. Then you're going to find your next smallest number, which if I go through my list here, it looks like it's a 40. So I'm going to add another stem of 4. And my first leaf there is going to be 0. Then I cross it off. Then the next one is another 40. Then the next one is another 40. Then the next one is another 40. And sometimes you can have as many 40s or little as possible, and it happens. So what I want you to do is I want you to pause the video and complete this stem and leaf plot. When you're done, it should look something like this. And the most important thing at the end here is that you have a key. And the key tells me how to read it. So what you need to do is you need to choose one of the values from your table. Doesn't matter. I'm just going to choose 35. And you're going to write it like this. You're going to say 3 line 5 equals 35. And the reason that we do that is so that you know that this is 35 and not 3.5 or 350. It just makes it easier to see. Now, what else this does is this creates kind of a visual representation. This would kind of be like a frequency table of all the 30s, all the 40s, all the 50s, 60s, and 70s. And so if you kind of turn your page and look at it, it looks like a bar graph. And we could even tell that this is kind of skewed right a little bit. The tail is to the right of the data, which is interesting. Now, to put this in Excel, because sometimes they might ask you to put this data into Excel, you need to be aware that you can't just type the numbers in. So in putting this into Excel, if you have a stem and a leaf column, the stems is going to be pretty easy. It's just going to be 3, 4, 5, and 6. But to make sure they are easy to read, you want to make sure that they are on the right side, so you want to use this if it's not. And then the leaves are where it's going to be tough. You want the leaves to be on the left side, and you want the leaves to be even spaced. So if I come in here in the leaves and I just type 2, 2, 5, 5, 5, 6, it's not going to look right. It's going to be very hard to read. So what we need to do is we need to talk about formatting a little bit. First of all, if you're typing a number into Excel and you don't want them to change that number, you don't want them to make any alterations to it, what you're going to do is you're going to type an apostrophe first. So if I type an apostrophe and then the number 2, I'm just going to leave it as a 2. It's not going to move it. And notice how it keeps it over there on the left side. Well, then the next number I want to type in is also a 2, but I don't want it to be right next to the 2 I already typed in and look like a 22, so I'm just going to hit space 2, space 5, space 5, space 5, space 6. And that makes it a little easier to see. So that's how you type that in on Excel. Now the next thing we're going to talk about is comparing two sets of data with a stem and leaf plot. Sometimes you'll see something like this. I'm not super picky on if you know how to make one of those. I just want you to know how to read one of those. So this says home runs, hits per season, Babe Ruth versus Barry Bonds. The middle column here is the stems, and each one of these over here is the leaves. So you can see that this season Barry Bonds had 5 home run hits. That was his lowest. And then Babe Ruth over here had 0 and 4 and 3 and 2 and 6. But down here, Babe Ruth had 54. Or Babe Ruth had 46, 49, whereas over here, Barry Bonds had 46, 42. The only thing I don't like about this is that this is not in numerical order, and that makes it really hard to comprehend. But let's answer some questions about this to make sure we comprehend. So on number 1, it says, what is the largest number of home runs that Barry Bonds achieved? So if I go over here to Barry Bonds, I want the largest number of home runs. So I come down here, and that's a 73. Then on number 2, it says, what's the lowest number of home runs that Babe Ruth achieved? That would have a stem of 0, and the smallest number here would be 0. So he did have a season where he had no home runs. The next thing we're going to talk about is a dot plot. Now a dot plot is a graph where each data value is plotted as a point above a horizontal axis. Now you notice some of these are stacked up. That just means that we have multiple. So here we have 75, 75, 75. There were 3 values that were 75. So it kind of looks like a bar graph mixed with a dot plot, which is really interesting. So let's, again, I'm not super concerned that you know how to make this, just how to interpret it. So on number 1, what is the highest number of wins that the Chicago Cubs had? The highest number of wins would be the very far to the right. Now we just have to figure out what they counted by. So we had 95, 1, 2, 3, 4, 5. This is 105, so they counted by 2s, 95, 97, 99, 101, 103, 105. This would be 103 wins that they had. Then number 2 is what is the lowest number of wins that they had? Way down here, again they counted by 2, so this would be 35, 37, 39. So halfway in between those, that would be 38. And then what was the most frequent number of wins that the Chicago Cubs had? Would be this really tall guy here, so that would be 77. Next, we're going to talk about a time series plot. A time series plot is also known as a line graph. You guys have done these a million times. We're just going to do a quick run through to make sure that you remember. So Jessica recorded the temperature in her backyard in degrees Fahrenheit every hour for a 12-hour period starting at 8 a.m. The results are shown on the table below. Create a time series plot to represent her findings. So the first thing we want to do is come up with a really good title, and the really good title is already given to us, Recorded Temperatures for August 1st. Now we're comparing the time with what temperature it was, so I'm going to come down here and put time on my x-axis. And since this is a time series plot or a line graph, I'm going to label my lines, not my bars. So it started at 8 a.m. and went all the way to 7 p.m. So I'm going to start here and I'm going to go 8 a.m. and then 9 a.m., 10 a.m., 11 a.m., 12 p.m., 1 p.m., 2 p.m., all the way to 7 p.m. Then we need to label my y-axis. Now my y-axis is talking about the temperatures. So I'm going to say this is my temp, but I make sure I label like how we're measuring it. So in parentheses I'm going to put in degrees Fahrenheit. Now I need to count. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 lines, and I need to get all the way up to my max temperature. And if I look quick, my max temperature is all the way up to 88. So 14 lines, I need to get up to 88. There's a bunch of different ways that you could count. If I count by fives, I'm not going to quite make it. Could count by, some people would suggest maybe count by sevens, maybe count by eights. That's a little weird. I'm going to count by tens because it's easier for me. So I'm going to start here. I'm going to go 10, 20, 30, 40, 50, 60. And then we're just going to go through and we're going to put our points. So 8 a.m. is at 62 degrees, so it's not going to be perfect. It's going to be right above that line 60. You put a point. Then 9 a.m. was at 66. It's a little over halfway. And then what you're going to want to do is you're going to want to connect those with a straight edge. I'm a pretty specific person. I like things to be straight, so I use a straight edge. On 10 a.m. it's going to be 70 degrees, which is right at that intersection, and then I'm going to connect it with a straight edge. So what I want you to do is go ahead and pause the video and finish this line graph on your own. When you're done, your line graph should look something like this. Now, we have talked about this in the past, but something that you will see a lot with time series plots is if they are stationary or non-stationary. So we can see that this series below right here is trending upwards. It's going to keep going and going. That's a non-stationary trend, whereas the one that we just did, how it's kind of like staying steady, going level, that is a stationary trend. Also, if it's trending downwards, that would be a non-stationary trend. Another thing to look out for is it's not uncommon to see time series graphs with multiple sets of data plotted. Here's an example of that. You just have to be really, really careful. This is a big way that they can get you. Is check the vertical axes on both sides. So over here, you'll see that they have a color-coded key here so you can see which goes with which, and they have different scales for each graph. So sometimes, like this is a good example of something that does work because yes, the scales are different, but they're trending at the same rate, so you could see that there would be correlation there. But sometimes they will alter the scales and really try to trick people by making data look like it's more related than it is.